This was presentation from last week. I said last week, sorry, 2 weeks ago. That was the 22nd of May. And we just ran through a couple of frameworks where we discussed what AI agents are. In this session, we spoke about basically an AI agent is a component of a product. Now, today, what we're walking through is how to make AI agents into features within the product itself. And that's where we are. So that's AI agents as product features, the integration, and possibly the road mapping. So I just want us to think about this as, if I want to put an AI agent as a product feature, we shouldn't always think of it as just being a chatbot itself. We should think of what the AI agent would do in the context of the solution that we're working on or what we're doing. And like we said, we have the perception layer, the decision layer, the action layer, and then the goal. The perception layer is basically, as this AI agent, I'm observing my environment. It doesn't have to be a physical environment. It could be, what is the customer currently doing, or what's the user currently doing? Then the decision, how do I help the customer or the user achieve this? This has been set as a goal. And then I take the action with some level of autonomy. That's what the AI agent is doing. And the level of autonomy will vary based on the exposure that I give or the level of integration I provide to the AI agent. So they need to move beyond just prediction to autonomy. So, and that's the difference between what the AI that we currently think of. So if today, you're thinking of AI in your solution, you're thinking of maybe just building like a classification model. It's your data science team that is doing something for you. But that's a bit different, right? Today, you want to be able to say, okay, this particular customer has come in and this particular customer is trying to solve a problem. And the customer is going to get frustrated that the customer is going to drop off. I notice that the customer is about to leave the page and I decide to tell the customer, oh, hi, Lisa, it seems that you want to leave currently. And I understand, based on the fact that this agent has access to customer data or the tracking here, the agent knows that typically customers are leaving because of the complexity in maybe this onboarding flow. And instead of doing that, I'll call it like the onboarding layer that we tend to have with solutions. Like I think Iterable has something of that nature. I decide to say, oh, are you struggling to do this? This is how to do it. So I'm able to specify for Lisa and to ensure that the goal there is to ensure that Lisa has the right onboarding experience. And I can do it. Or another example would be, we want to integrate an AI agent into the abandoned cart problem. Then at the point of exiting, if there's an option to provide a discount as opposed to that, I call it, it's kind of silly. I don't know if you see it a lot. You go to a new website and they tell you that you get 10% discounts once you provide your email. And that thing is almost automatic. So I just feel like the 10% is always factored into the price and the discount isn't real. Because you go to a website, the moment you want to do anything, the first time you go, maybe you go from a storefront on Twitter, and the moment you get there, you see that the first banner you see is that 10%. Now imagine you converted that 10% into a coupon code that's driven by the AI agent and based on the flow, can then determine the success of each of those without necessarily going through the standard A/B testing experimentation phase. So this gives us some flexibility in that way. And because we can actually score the agent, we can actually just improve. I'll run through the integration frameworks and road mapping, but I just wanted to establish some background here. So what really made AI like transformative here is really, LLMs have gotten to a point where we have different expectations, to the point where I say we almost get rude with AI. You have that mindset where I expect you to kind of know what to do. I'm not expecting to have like I'm not expecting to have like an interaction with you in that way. I'm expecting answers, and I'm also expecting you to be able to take some action in terms of like tools. If you go to ChatGPT today and you're using one of the GPTs and those implementations, you can get things like that. But let me actually run through my presentation. So agent adoption has like 75% of companies have plans for AI agent integration by 2025 in some degree. Capacity will vary, but there's a McKinsey report that has this information. Then, like I said, users have an expectation that there's an intelligent automation that will happen. And based on work by the CRM, that's Salesforce, agents resolve problems 65% faster, mainly because they have access to the entire pool of information. So now, next thing we then have is the competitive moat. Now, in this case, you want to ensure that how do I have a competitive advantage by integrating an AI agent? Do I ensure that my people are more productive? Do I ensure my customers are more engaged? Do I ensure that I have lower churn? Do I ensure that when my customers come around, all my users, I make that distinction or delineation, because you could be building internal solutions, which is more of my forte now. And I have more users and customers. I get their requirements, but like I said, I don't necessarily have to build the prettiest things or to get them to work, to get them to use the tools in the way, because it's necessary for our organization. I'm sure most of us here are already using AI tools in some way. So the idea is now, how can I take the core component of the AI tools and integrate them into my product before my competitors do it? So that's really it. If you remember from our last session, and some of you were not here, but let me see if I could just show you an example that we ran through. In the last session, we ran through a programmatic prompt, just a design here. And the idea here is it should analyze data and create an optimized query. Now, if I have users that need this within my organization, this is basically like a pseudo example of what they need from me. So I'm telling, okay, this is how it needs to be done. Now, this person who is a data expert might have written this query and gone to ChatGPT or gone to Claude's, Anthropic's Claude or Gemini. We use Gemini internally, and ask this same question. So I'm trying to go to a large table with this. But because we now have this as an option within the solution, this person can then always get this result, as well as whatever considerations or computations or reporting that will be generated from this. This is fictitious, by the way, just trying to explain. So things like this is already, this person could have just done this part, but now by putting that directly into the settlement and reconciliation internal tool with optimized queries, then we can have some level of improvement across. And that's what this is. So this is a system prompt, this is the user prompt, and this is the information that we have here. Here's just an example of things that we can achieve with this. I'll go back to our current presentation. So now we're trying to move our AI agent from just a tool to a teammate, which is, we're saying that this is what traditional AI is. You basically are waiting for the user inputs. You have limited memory of interactions. There are typically no set goals, but with AI agents, you're basically saying, this is it. Obviously, learning from outcomes from our last session, I explained that it's possible that you have an AI agent that is very narrow in scope and is just taking repetitive action, but always has a goal in mind, but does not have a memory thing. So the memory implementation in AI varies, and I know I haven't shared it, but there's the documentation that I was supposed to share on resources that explain the different type of memories that agents have. You have the short-term memory and you have the long-term memory implementation in AI, and I will share that later this evening. Then we also have AI making the decisions here, and then also the ability to perceive the environment continuously, which means, in an example, there's a particular implementation we have where I want to get data from a particular source, but I need to be able to pass the information and understand the fields for settlement and reconciliation processes internally. Now, if there's a failure there, typically I would need to write a regular expression to understand the new transaction and decide how the transaction should be settled for that reconciliation. That's the process. Now, by switching that out to an AI agent and telling it you are a regular expression expert, when this file fails, I want you to take this transaction and generate a pattern that is either closely linked to a pattern I currently have within my system, if there is one. So you expand the regular expression. A regular expression it's a way of passing information so that you can generalize text. And if there's any pattern in it, you can also define that pattern. So that's what we do with some part of the work that we do internally. So I can tell it to expand on that, and that makes it, then that solution takes out the engineering work and stops delaying the people in the operational team when it comes to what they need to do. So that's why you take the AI agent in the internal use cases from just a tool to a teammate where it adds value internally. And that's the example I was trying to explain. Now, AI agents have benefits with the implementation. They can provide proactive assistance. They can be autonomous, and they can provide hyper-personalization. That idea of just knowing a bit more about you and processing that information to just treat whatever issues that you have. It has a way of making you feel special in some way, because that experience is unique to you, your data, and your experiences. It's basically, I think it's Eric Schmidt that said it, where Google is going to go to the border of being creepy and stop there. Like, they have so much information about you and create such experiences that it feels like you have this one-on-one experiences and you're like, you know me in a way. Like, the intelligence makes it feel like you know me a lot, maybe too much, but then the result you're giving me is so hyper-personalized and it's so useful that I'm like, is it really a problem? So that's where obviously the conversation of how much data privacy, ethical AI, and the use of your data and things like that will come in. That's a different conversation beyond the scope of this session, but just as you can also tailor product experiences in real time. And like I said, user preferences, this automatic optimization of your user preferences is also a really nice touch. So now this is the roadmap in part, a roadmap for AI agents. So you have the Let Me Help You agent. They're also called concierge agents. This is sorry. This is an agent that has a very narrow scope. It tells you, let me help you, what do you need to do? It launches as concierge. The initial goal is just, you take one workflow. The example I just provided about an internal AI agent is that. It's a concierge agent, basically. It hijacks that process that used to be human, and it does this. Then this is the integrated agent. This is if you build a solution and you integrate the agent intelligence. It's basically, imagine you were doing a call, an LLM call here, and it's directly integrated, but not just to a user action, but this time to the user experience itself. So it's can be used in spaces like, so you have smarter search results, and you can also have things like this, which I find very interesting. You can have buttons that are context aware, and that means you're creating buttons they don't necessarily exist, but they are basically taking complex workflows and treating them with a button that solves the problem here. And then you have the completely autonomous agents. This one is trickier, but the agent will operate throughout the entire application. You can use and connect to external services. Now, I'm sure if you're following the AI agent space, I'm sure recently you realized that there are a lot of ways to connect to external services, and there are even ways for agents to talk to themselves. And one of them is Anthropic's MCP. which is a communication protocol. So they are saying if Claude, if I want to communicate to this service, instead of creating a custom integration every time, this particular service can create an MCP implementation, which anyone can then connect to. So they're trying to get people on board. So it makes it easier to connect to external services for things that could add value to you. So let's say you had Intercom, and Intercom now has an MCP. Then you want your application to understand all customer issues that exist and understand why a customer might be experiencing a similar issue. This kind of thing might not even get to your customer support team because this thing has enough context. Then if you remember, we also had the conversation about, in the last session, I'm going to stop assuming you do, so I'll just reference it. I have it in the background in case you were not in the earlier session. Well, in the last session, we spoke about hierarchical agents. I want to share, let me get them for here. The different type of agents that we have. Yeah. So we have the different agent system architectures, and we have these hierarchical agents where you have a manager agent delegating to specialized sub-agents. So imagine in a situation where we're actually speaking to this Intercom, picking all the information. I can then create a thread that's basically a thread of customer support who are dealing with different issue types, and they're basically specialists in each of those issue types. So that's what we'll be able to do here. We can also build, obviously, a hybrid system. But in the context I was speaking about, it's just this, and that'll be a good example. So we're back to this. So things that we could achieve with AI agents will be enhanced user experience, automation and efficiency. We can completely new experiences. I won't call on anyone, but if you would like to speak on some thoughts you have on any of your favorite application or something you're working on currently, and think of how an AI agent could add a new capability, that would be appreciated. If not, I can go on. Is there anyone who wants to speak to that? Okay. Then we have the competitive differentiation, which is where you stay ahead with truly intelligence. And okay. So the next thing is, where do agents fit and how do you identify an opportunity? Now, before you obviously go into integration and road mapping, one of the things you need to know is, in the current solution I'm building, I'm a product manager today. What opportunities exist? Are there repetitive tasks? Are there complex workflows that I worry that might be difficult to resolve? Are there places where I think there's too much information and there's information overload that I can simplify because I can provide an agent who will do the data crunching? Is there a way I can provide proactive assistance to my customers in some way? Next thing, can I provide personalization? And do I think personalization has benefits to my customers? Because obviously, as most of us know, personalization can be incredibly expensive. And it's compute heavy, which is where the costs accrues to. So if you can tailor this interaction simply by optimizing the agent interactions, if you remember, no, I'm not going to say that again. From our last session, we spoke about how to make cost considerations when you're doing agent design, and that's the framework here. Where we spoke about the MATE framework, which is you select a model that balances capabilities against costs, action specificity. You ensure that you do your token efficiency. Token efficiency is you optimize your prompt and you use the LLM to do the prompt optimization as well. Then when you figure out the prompt, then you typically will go to this type of design. And then you specify the user input, minimize it, set this value, and set the temperature. So things like this are things that come as a result of you building your MATE framework. And then you also do this, you ensure that this can work within the confines and the environment. Like I said, perception of the environment. And this is the environment in which it will be working in. So we're back here. So you have this. It's just this again. Repetitive task. Okay. All right, so now this is integration approach from augmentation to autonomy. So you have two types of integration that I'm going to speak about. They might not be limited to these two, but these are the two that I understand and will provide context on. We have the shallow integration and you have the deep integration. So the shallow integration is basically the agent as an assistant. The user initiates, but the agent is assisting. It just augments existing features. It's usually low risk and a very good place to start. You're not going to start by building an AI agent that's going to create customization for all your users and then ensure that it drops your churn by 15%. That's not the first AI agent you're going to build. That's going to be an expensive AI agent and it will be harder to justify to stakeholders. So you're obviously going to route it through, let me take a monotonous process and let me create an AI agent for that. Let me show the value of that, then you ramp up to that. Obviously, if you're a CPO or a CEO in this session, that might be a different conversation. But if you're a product manager, whichever variant, pure data or AI, you might need to provide justifications before you get all the way to deep integrations. So you have agent-initiated actions. Basically, at this point, the agent is, once I see this set of things, I'm just going to, on my own, take action because I've been trusted, I've been tested. I can generate my own intelligent workflows. Like I said about the hierarchical agents, I can do that. Obviously, it's higher risk, but the reward will definitely pay off. These are places where you get fantastic opportunities to do new things. And you have the automated, an example would be an automated expense submission. So this is just a sample roadmap for what you might want to do. So you, like I said, this is road mapping agents. Build your trust incrementally if you want to have conversations with your stakeholders. So this is MVAP. We spoke about MVAs. So this is your minimum viable agent. I don't want to put it, just call it an MVP again, but it's the minimum viable agent in bracket, basically the product here. And then we have the phase 1 experiment. You create an MVA, you iterate, and then you try to build an ecosystem of agents by the time you've designed what you have to design. In terms of how the ecosystem could work, you could create a sequential agent structure. Sequential is one agent speaks to the next till you solve the customer's problem or whatever you design. Then you also have the hierarchical. In that situation, you have a manager agent who is looking at, so you can have a customer support manager who is managing multiple threads. Think of your customer support team today or customer success team today. How can I help a customer succeed to activate their card? How can I cause the customer to succeed to carry out a transaction? So when I take those type of logical threads, then I can say all those agents speak to the manager agent, and then whatever optimizations I need to make across, I can now send it back from the manager agent. So if you are thinking of it in terms of cost structure, the manager agent would be the most expensive agent in that particular flow. So navigating the agent landscape. So you have the trust and control, error handling, data privacy issues, and performance. Performance is tied to the MATE framework, like I mentioned. Trust and control. Undo is important. You see it a lot, even from basic implementation on your LLMs today. You see there's an option, if you make modifications to your documentation, you see the version controlling, and you can always go back to the version. I'm using how Claude works today. Human in the loop. I'll go back to the image that we have. So just explain this further, and obviously the data privacy concerns that I raised earlier. So these are ways you can measure customers' agent success in the how successful are they with a task completion, how much time is saved, what's the user satisfaction score, and what are the error rates. So this is just a structure that we have for an AI agent in terms of integration, in terms of road mapping. So I wanted to go with a practical example. The one we started with earlier, and just provide some context. Just give me a second to just load that up. Is the font large enough?
No, it isn't. Oh, yes, thanks. It's good now. Thank you.
Okay. All right, everyone good? You can all see this, right? But like I mentioned in the last session, I didn't really get to delve into it, but the idea was if we were to build I mentioned the problem that we had at the last, in my prior organization, and we had to deal with a traditional product management approach. But imagine if in a case where I was to build this again today, how would I go about building this? Or how would I go about solving this particular problem? So the issue we had was we're speaking to a legacy system, and this legacy system was resulted in our card activation being hit and miss. So let's say about 70% or 80% of the new virtual cards that we would create, or cards in general, but virtual cards were an area that we're focusing on specifically at GoMoney at the time. 70% of them will get onboarded on the safe token platform of InterSwitch. And that means 70% of the cards means that for every 10 cards, 7 of them are activated, which means you can use them online. However, for the remaining 30%, there was no activation happening, and those customers were basically saying your card isn't working. And in the landscape we're dealing with, we're coming to tell people that we had cards that could work and you could activate them without needing to go to a bank. So our marketing message was very clear. Come, get a card that works and you can use for international transaction. This was before all the, dollar madness. But just before the dollar madness, around the start of it, up to the $100 limit that we had in Nigeria at the time. So the entire essence of our card, our marketing campaign was, we're bringing you in. This is a profitable channel for us. On transactions that are done internationally, we could earn as much as 6.5% of those transactions. On those transactions are larger ticket transactions. So this was a no-brainer and it was an essential thing. So the essence of us bringing you in was we could generate money on the card generation, the card creation itself. We're charging you 1,000. The cost at the time cost us $350. We're making the card at the time cost us $650. We're making $350 on every card that we issued, as opposed to physical cards that were a loss leader. We're expecting that because of the frequency of physical cards. So instead of losing money, I'm having like a profit poppy here, basically saying for every virtual card, I'm making $350 and I'm making 6.5% on international transaction, and between 1.5 to 2.5 on local transaction, depending on how it's processed. So it was a sweet opportunity for us, but we're running into the bottleneck of the legacy system. So if I were to build it today, it will be so much faster. And this is how I'll go about building this. Then we go to the card issuance controller, an activation specialist. I will speak to the legacy system integration agent. There's a user experience agent, a diagnostic agent. it's identifying the error patterns. We knew what the error was, but if at the time I had not done this evaluation, I'll go here to identify what the pattern of the errors were, design a system response analyzer, and activation validation. So this is the workflow for something like a hierarchical agent. So now the master controller agent here is basically the entry point for all the virtual card related issues. And it's to tell you basically, how should I route this transaction? What is the problem this customer is having? Now at the time, all our issues, or majority of our issues, came as a result of not being activated on the legacy system. But we had, for a brief period, we had a unique issue where we're creating cards that were already expired. So that was another issue. And that would have cost us, that's where this would have come in handy. But that was an issue on our side that didn't require. It would have just told us, oh, you're making a mistake at the point of card creation. So we're creating the cards and also deactivating the cards. There was a problem with the way we designed the system at the time. And so the customers would see a card, but that card was already deactivated. And the moment you deactivate a card on that platform, you can't reactivate it because the assumption is maybe the card is lost. So the idea is the customer should generate a new card. So we're taking both actions at the point of creation. So the diagnostic agent would have shown us that and how to approach it. Okay. Are we all good? Okay, then.
Yes, we're following.
Oh, then we'll go to the card issuance. This specializes in all card-related processes. It coordinates between the specialized agents that we have here. Then we can also use this to track the resolution progress. Activation specialist agent here. This is strictly on, is this card activated or not? Now, why this is, let's think of this in the context of integration. Let me go back to this. The first approach I would take is shallow integration. Is an agent that can be integrated into our internal support tool and monitor how the virtual card issuance stream and what are the activation logs there. So the process I took then was simple. We'll go to the list of all the activated cards and compare them to the list of all the created cards. So whatever cards were created and were not activated, we will then pass via API to the legacy system for another retry, another pass. There was a chance that another 30% of that, but we're just reducing the surface area. And I know you're thinking this is not sustainable, but the reason we could not actually get our own card system was the cost of the card system. So card systems are really expensive if you've worked in a bank or if you worked in the fintech space. So that was it. So I would approach it from a shallow integration, and this is user initiated. The user here is the member of the customer support team, or it's just agent assisted. So I would do that and identify all the issues, flag the cards for the operations team. And then when I send this again to the legacy system, I'll then go and check the card status, thereby just iterating over the number of cards in the pool, while I'm also sending messages to the customer. Hi, your card has not, we know your card has not been activated. Hi, Lisa, your card has not been activated. It will be activated in the next, it used to run in 6-hour cycles. So let's say we picked up the first batch by 8 a.m. Your card will be activated by 2 p.m. By the time we check again at 2 p.m., we'll compare, oh, this card has been activated. We'll send the person a message, thereby allowing the customer know that they've created, the card has been created, activated successfully, and you can now use your card. And you know why that's a win-win? There's no way we could get our customer support team to send those messages every time. And the alternative will be to do an API call at the point of activation, but then the customer doesn't feel like my issue is being resolved. Or in some cases, it's until you want to use your card, you might activate it, but like, I don't have a need for this just yet. By the time you now want to, then you're like, oh, this card doesn't even work, and you never come back to our application because of that. But we'll tell you that, oh, hi Lisa, your card has not been activated just yet. it will be activated in 4 to 6 hours. It was 6 hours at the time. At 2 p.m., we would go back to the legacy system, get a list of activated cards in 2 batches, the new cards and the ones that we sent for resolution. We had a higher success rate for those we sent for resolution for some weird reason, but we don't need to delve into that. So we could then say, oh, so let's say 9 out of those 10 cards were then activated. And then
Hi, Wale. Can't hear you anymore.
hi, sorry, can you hear me now?
Oh, yes, I can.
Yeah, I apologize. I was getting a call on my computer that spoke to me. Yeah. All right. Sorry, as I was saying, in a case like that, so 9 of the 10 cards will get activated in the new batch. And then we send another message to the customer. So that allowed us what I'll call the shallow integration implementation. The next thing we have is deep integration. This deep integration is how would I apply deep integration in this workflow? I would I'll create an RPA process. As RPA is robotic process automation, which is basically for every card that has failed, I would automatically retrigger this. Basically what we've already done, but with the agent itself connected to the legacy system, as opposed to our system being the trigger here. I will connect the agent directly. One of the external services that will be connected to will be the card system, the legacy card system that was failing. And for that, it will go through an iterative loop. Basically, like I said, 7 out of 10 originally. And of the 3 out of 10 that failed, there was another 90% success rate, which means for every 30 cards that failed, 27 were treated, and we still have a possible failure rate of 3. And then keep iterating like that, talking to the legacy system to ensure that all cards are activated and we have the best experience, because it was our marketing move and our marketing message at the time. And it was really important that we did that. So that's how I'll go with a deeper integration, but to obviously go to a situation where you have that level of trust in your legacy system and your agent speaking to the legacy system directly, you will need to get a lot of stakeholder buy-in. And for you to have the stakeholder buy-in, it's back to we have to go with the shallow integration, basically where we get, it's a high value problem, but we'll just go with the basic functionality. Then before we get to this, where we'll connect agents to more systems and introduce multi-agent collaboration if necessary. So we would have been able to solve that problem by simply showing people the value here and going all the way and getting up to phase 3. And then we could do a further expansion with this. So now this is a sequence diagram for how this would have worked, just an expansion on what we discussed earlier. So we have the legacy system, card activation attempt. This is the monitoring agent. There'll be a real-time analysis to the diagnostic agent. Successful activation, it will log the success to the monitoring agent. Then we have the failed activation. This is this box here. It will report the issue to the card issuance control. This will trigger the fixed implementation agent, and this would then apply fixed pattern. If I were doing it to a deep system, if I could fix the legacy system, I would do apply fixed pattern. This is a mermaid diagram, so I can't drag. Yeah. Just a quick preview. So you just apply the fixed pattern to the legacy system, and then if you're able to resolve it, you report the resolution to the card issuance control. So if there was a way to fix the legacy system. That's where this apply fix pattern will come into it. There's the continuous monitoring and the intervention. Then this is how it will work as well. Another sequence diagram within the customer resolution framework. The customer report an activation issue within this raises a support ticket. It routes to the card issuance controller again, our friend from Elling. This delegates to a specialist. So this is the hierarchical flow, which is it says, oh, this is an issuance problem. And this is the type of issue that it is. I'm going to send it to an activation agent to resolve. Now, obviously, you could have had humans in the loop here, understanding the nature with our ability to understand context and semantic understanding. We would have come here and say, oh, this person said that they had an issue with their card and their cards were not activated. But we'll run this independently and without the need for human intervention, thereby leaving the customer service to solve real problems, irate customers and things like that. It queries the card status on the legacy side, provides us the details for the failure. If it was early on in our life cycle, they have told us that we activated and deactivated this card, it's a deactivated card. Or it's an issue where we didn't create the rights. The system did not create it. So it applies the fix, confirms fix has been applied, provides resolution to the customer, and tells the customer how to verify. This is a selling opportunity. You cannot put your card on your Netflix, you can put it on Spotify, or if there were marketing opportunities, additional marketing opportunities. At the time, we partnered with, I think, Suya Bistro, because, oh, you can use your card now at Suya Bistro. And so something like that. That was the flow we had here. So this is just the customer interaction and resolution and how quickly it will take. And those are the key differences. So this is just a practical example of what shallow and deep integration could look like across different sequences of events. This is if I want to do proactive monitoring and real-time issue detection, and also had the flexibility to fix the legacy system. I would implement this way. In a case where that was not, I will go with this. All right, I'm ready to take questions now and provide any additional context, but that is the end of my presentation. Thank you.
Thank you very much, Wole. That was very insightful as usual, and I'm very sure people have questions. So please, if you have any question to ask Wole, please you can use the raise hand feature and ask your question, or you could type if you know you don't want to like unmute your mic to speak. So do you have like anybody that has any question? Okay, we have Gideon. Hi, Gideon.
Okay, good evening, Esther. Can you hear me? I'm in a noisy.
Yes.
Okay.
Yes.
So, I wasn't really paying attention very well. So I don't know whether we can get the slides or the recordings, because personally, the current company I work for now, they are building a lot of AI agents and framework for AI. So I don't know. I've been struggling. So I really need this so that I can make me like adjust better to what they are doing.
So do you want to like probably like talk about one of your struggles? Probably Wole can help provide context into like what you could do better or something like that. Hi, Gideon. Can you hear me?
I can hear you. For now, the place I am now, I can't really discuss that. That's one of the reasons. But I don't know whether I can like have access to the slides and the recordings.
Yeah, sure. The slides and the recordings will be provided. The recording will be uploaded on our YouTube page, while the slides will be shared on the Slack channel or something when Wole shares them also. All right, I hope that answers the question. All right, we have Oyedika. Oyedika, you could unmute your mic and speak.
All right, thanks, sister. Thanks, Wole, as well. I think my question is on, you mentioned something during the presentation about MCP. It's quite popular now. Can you help like break it down into more simple terms? Because it's kind of a buzzword, and for me personally, there's lack of clarity on what exactly it does or like how it functions. And then secondly, like evaluating these agents basically. So you've implemented an agent, like your diagnostics agent in the example that you gave. How do you run evaluation to know like the performance of that agent and just ensure that it's not doing like false positives or things like that?
Okay. Sure. So I didn't get your name.
Onyedika, Samuel, whichever
Okay.
one. It's fine.
Okay. Hi, Yudika. So yeah, so MCP, I understand the buzzy part of it, but the MCP is called the Model Context Protocol. The idea is, how do I connect an AI agent to a solution? Like before we get into the technicalities of what an MCP server is and the server client relationship, which is buzzy again, let me just explain what the objective of the MCP is to enable any AI assistant to connect to a data source in a simple and consistent way. It's like creating that secure plugin. It's equivalent of creating something like an API to a particular service, ensuring that your AI tool specifically can speak to that. So the way it works is you expose certain resources on a server, and then this server, the resources, they could be files, they could be database connections, even API endpoints, or a series of API endpoints. And then an AI tool like Claude, ChatGPT, your Gemini regardless, can then connect and use this particular server and these resources. It also allows you to say, let's see, the phrase this. You can basically call this to create files, to run queries, and you can also use reusable prompts. So imagine if I was connecting to ClickHouse consistently on the data warehouse, and I was working at ClickHouse. I could say that to ensure that whatever Claude wants to connect, or basically any AI assistant, but I always use Claude. It's the one I tend to use more, so it's top of mind for me. So if I want to connect Claude to ClickHouse to get data consistently and generate reports for me, I don't want everyone to create like a custom connection to ClickHouse. If I'm thinking of the compute, if I'm thinking of the optimizations, I would simply say, this is the way to connect your AI tool to your ClickHouse server consistently. And these are the parameters that you will always pass to it. And that will ensure that your AI assistant, Claude in this case, will be able to connect to MCP consistently. Esther's AI agent, ChatGPT, will be able to connect to ClickHouse with the same level of consistency. Obviously, because MCP is by Anthropic, and though it's open source, I'm not sure if they are as excited. If OpenAI, for example, is as excited to make sure that is available, readily available. I'm not sure, but I know like there are other AI tools that make it very easy for that to happen. So yeah, that's how that works. And I think you asked the second question, but I might have lost the thread now.
So thanks for answering the first one. The second one was on like evaluation. So like, how do you, in like real life scenario, like how do you actually evaluate these AI models? And is there a way you currently maybe retrain or improve the agent based on certain parameters or evaluations?
So the evaluation framework that works is when you set out a certain goal for your agent today, there's the way you measure it is task completion and the ratio of task completion. That's basically the error handling. Let me show you. I think we have it here. Let's go back to that. Okay. So the success rate of agent actions here. So using the example of my virtual cards, if I had an agent that was in my virtual cards today, the number of cards that failed to activate on a daily basis and those that were activated by the agent and the ones that were dropped. Basically, I told you I'm using 100 card sample size, 70 of them were activated, 30 were not. My expectation is that this AI agent will pick the 30 cards. Now, in a case where it doesn't pick the 30 cards, that's a first failure on its part because all those 30 cards failed and there was basically a query. Basically select everything from card created and compare that to card activated. So that is a first success metric I would take. And the second success metric I would then take is of those 30 cards that you sent again to this legacy system, how many of them were activated and how many of them were not. Now, the reason a card is not activated in this flow could be one of two reasons. The reason I mentioned of we were making a product mistake where we are activating and deactivating cards, and then the actual failure of the legacy system. So now, if it doesn't give me the right responses for each of those cards with my expectation, again, just using the 9 out of 10, the 90%, I would then say of the 27 cards I expected you to activate in this batch and give me responses on 30, how many of them did you do? So let's say of 30, only 28 were sent. The success rate is 28/30 in the first metric. If of the 28 you sent, I expected a 90% conversion on this based on historical information, I would say of this 28, that makes complex math, but 28%, 28 times 90%, what that should return 26.2. And then I'm setting that 25.2 expectation on that. If I don't get those scores, then I can then benchmark it and say, if I get scores below this, then the agent isn't working as it should. Now, if you're saying that you want to then retrain the agent, I think it's better to understand the agent before you would actually get to the point where you're thinking, oh, this should be completely independent and it should think on its own to fix its own problems. But in this particular situation, I would rather you, Yedika, go back to understand why are there failures and are there things I'm not accounting for in my particular workflow. Like if I'll go back to this part, my pattern analysis. So I can switch this pattern analysis. If I take the pattern analysis portion, I can then choose to say, oh, in this pattern analysis stage, I should make modifications to it, or I can make this itself a prompt and then create an agent that will basically understand what patterns exist here. And these patterns, then I'll do solutions efficacy evaluation for this, do knowledge-based updates, agent retraining, then I'll do this resolution data collection. So this is how I'll do my system learning and continuous improvement if I were to add this. But because I said I will do shallow to deep integration, I would prefer to do the pattern analysis myself to understand it. It might not be as robust as one thinks, and I will take this step first on my own. But if you have all the resources, then you can also find a way to design an agent here, similar to what we were discussing here. And you can then go here and create your own diagnostic agent. And this diagnostic agent will be the one that will handle step 4 for you, the pattern analysis stage here. So that will be how you do some of the improvements with a practical example.
So, sorry if I'm asking a very redundant question, but each of these steps now, each of these systems, are they agents on their own, or are they like prompts within one AI system?
These are agents on their own. This particular one is another agentic system on its own. It's not going to be a single prompt. Resolution data collection, this is its own agentic system, and it could be a series of agents. So like I said, in this particular workflow, I'm thinking pattern analysis should be an agent, but I will do this on my own as a product manager. Check if this solution can be fixed. How effective is this solution that I have suggested? Update my knowledge base so that this can be done. then retrain the agent with this. And retraining the agent will involve me going back to this could just involve me making this type of modification. So in this, my user prompt, I'll make certain modifications to deal with different user types and provide more flexibility in the user prompt design. But again, our experience here is not building completely autonomous agents. It's still user triggered here.
Mm. Okay, so I want to respect time. I don't know if I can still ask one more, or if not, I'll just.
Yeah, you can go ahead, Erika.
Okay, so
You
just,
can go ahead for me as well.
Yeah, you mentioned something about like fully autonomous and then the triggered. Have you experimented between the two different models, like ones where you see it like a human in the loop, and then the ones where it's like fully autonomous? Are there any benefits between the other, maybe security wise or success rate or things like that?
Nope, I have not built anything that is fully autonomous on my side. But obviously, the benefits will, if you can get everything right in terms of full scope, like that's why I said the road mapping is important. Like building your complete roadmap. If you can get all the way to this, where you build this ecosystem, by the time you have multi-agent collaboration, then you can have full autonomy and you can have your full agentic workflow. But no, I have not gotten to a version of full autonomy, but it will always trump a human in the loop, especially if you have the right security controls or you're building processes around this and you have the right controls. A couple of things we do are like read only. I'm not giving like any right access. So you're reading data, you're analyzing, you're evaluating, you're making decisions, you're generating reports. If you're doing things like that, a system that operates with full autonomy I think is a superior experience. The human in the loop it'll be the equivalent of your V1. But your V2 will be the full autonomy. But I don't have any experience actually building a fully autonomous system just yet. But I would expect that the benefits will trump building a human in the loop system. Once you get to that level of comfort with an understanding of all the problems and understanding when you're experiencing failures, then you also ensure that your system can fail gracefully. It can revert from V2 when it starts doing complete rubbish and going to V1, which is the human in the loop.
Makes sense. Thank you so much.
All right. Thank you very much, Erika, and thank you, Wole. I don't know if anybody has any other question, and we can just call it a wrap for now. Anybody? Okay. So I just want to say thank you very much, Wole, for taking our time to talk to us again today, and really appreciate having you on this call. And I'm sure a lot of people have learned a lot. Someone is asking a question. Well, do you want to take that so we can wrap up?
Yeah, DSS, that's what CAD, I think, Ahmed, you're speaking specifically to the virtual cards. Yeah, we were PCI DSS compliant, so which meant that the data I was sending had all those controls, the masking of the bin, and I wasn't sharing any PIN as well. So because we had to integrate to the legacy system, we had to be PCI DSS compliant. In this context, I'm a subsidiary of Sterling Bank. It was Go Money. That's what you're referring to, right, Ahmed? It's okay. Yeah, nice payment card industry standard. So yeah, we were PCI DSS compliant, but you remember in this hypothetical situation where there was no agent here, I'm creating a hypothetical situation from a problem we solved manually and still needed operations people in the loop. They were the ones talking to the legacy, to the engineers to send these things back to the legacy system. So that was the workflow that we had. And so I'm not saying, oh, in a case where this problem happened in the age of this AI agent as opposed to 2020 when I was solving this problem, this is how I would approach it. So that's the difference. I hope that's clear. Awesome.
All right. Thank you. Thank you very much. Really, like I said, and I really look forward to the last session we'll be having for June 9th. And thank you everyone for like joining us today and staying with us this far. You guys have, whatever. And just like a quick announcement, we also have like other events you can benefit from. First of the webinar series happens every second and last Thursday of the month. And then we have the IPS interview prep session that happens alternatively on Tuesdays with the general mentorship session. And then we also have the bi-weekly check-in call. One happened last week, and I'm sure if you were on the call, you'd have, learned a lot and had the opportunity to, like, talk about your life as a product manager, get advice, and also like see how other people, it's not leaders in the shige, the other people that are also like experiencing some of the things you're going through as a PM. So on this note, I would say good night everyone and happy, is it Eid? I'm not sure, but to our Muslim brothers and sisters, and to enjoy the rest of the holiday. And thank you once again, Wole, for joining this call. Good night, everyone.
Right, and thank you for having me. Bye, everyone.
Thank you, Wole. Thank you very much. Good night.
Yeah, good night. Thank you very much, Wole. Olushola, hi. Good night.